Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels.
So welcome back to another lesson in the Ultimate CCNA Prep course, where we are prepping you to take the CCNA exam to increase your income, whether that be in a 9-to-5 or something in a entrepreneur spirit like selling your skills on Fiverr, Upwork, or creating a business. Now we actually, today is our first lesson in automation and programmability. I spelled that wrong. I'm sorry, y'all. But section 6. So over the weekend, we didn't have any classes. Basically, it was all catch up for a lot of people. There were some extra labs that I did give out to some other students so they can, get caught up to speed and make sure that they understand what's happening before we actually move on to our last lesson, which is, again, automation and programmability. Do not pay attention to my spelling error, whatever. So we're actually going to get into 6.1 and 6.2 of section 6. And this won't be too long. Actually, we're just going to go over about automation just in networking and then just do a little review with our labbing. Okay, there will be like a lab. I'll pull it up at the end so you guys can see how to go through it. But yeah, let's actually just get into it. All right, so automation in networks, right? I always keep this on my screen and it bothers me all the time. So let me do that. Okay, so automation in networks, right? We have traditional versus automation. So basically, what is automation in networks? It is just automating the configuring, managing, testing, deploying, and operating of physical and virtual devices in a network, right? So traditionally, what do? We use copy and paste to copy configs. We go into the GUI, whether that is a website that we 10.1.1, right? Remember wireless, that's setting up a LAN and setting up the security for our wireless LAN. We go into a GUI, right? Or we can SSH, right? We don't use Telnet, definitely remember. So we use SSH, and of course we're just going in remotely and virtually connecting into the networking device and doing whatever we need to do, whether that's spilling out outputs like show, run, right? We want to show the running config, or we actually want to configure things. We want to configure an interface or turn it off or shut it down, whatever the case may be. This is what we're doing manually. But when we're automating our networks, we don't have to manually do that. We can apply some type of automation method like a Python script, SDN, Puppet, Ansible, and many more, which will allow us to do these things for us. So we don't have to do that. Oh, I'm sorry. Okay. So we don't have to do that, right? And these are some of the methods we can use. Python is a really big one because it's very easy to learn. Anyone, whether you have a coding background or network background, it doesn't matter. If you're new to automation, new to development, then Python is great. A lot of companies actually use it. SDN, software-defined networking, we'll actually get more into that. Puppet and Ansible. I think we'll talk more about Ansible, but we won't talk about Puppet too much. We may, I don't know. We'll just see how this goes. But there's a lot of automation methods that we can use to help us configure, manage, test, deploy, and operate our networking devices. Right? So when you go out into the real world and you start working in the IT department, specifically in the networking department, you will see that a lot of companies are using at least maybe I'm going to say 80 to 85% of companies in the world are using some type of automation method. Right? And usually they have they have this either this one engineer in the department that actually is, delves into the automation or the dev side, which is, we may say dev, and dev means developer, right? Because it's kind of it's kind of segueing from networking, which is, what we've been learning about, and more into the coding of things. So you probably have this one engineer that actually goes on and learns more to help with the company, or they just work side by side with the dev ops team, right? The developer operations team to make sure that we can use this automation in our network, right? So what Cisco's done, because this is a new exam that we're prepping you for, right? This exam came out early last year. So what Cisco wants is Cisco wants you to kind of be like a jack of all trades. Like, I want you to go into the network, into the field, and actually know how to use networks, but also know security and also know automation, right? You're not just one thing. You're not just going to learn, just wireless or just security. You want to know a high end of everything, and that's what makes you employable, right? That's what's or you're able to market yourself better because you know how to put automation into the networks, right? Now, obviously, a lot of people, I'm not gonna say obviously, I mean, we would think like, why not automation? But some people feel, why would we use automation in our network? I mean, we can just hire, that's what we have our voice team, our data team, our security team for, so we all do our task and it all comes together, right? But when you think of it as just, let's just say we're just regular data engineers and we did a merger and acquisition and we have 30 sites, and these 30 sites have to actually come over to our network. So we have to ensure that they have the proper configs on their routers, on their switches, on their servers, the DHCP. This is our pool that you're using from. And imagine that's for 30 sites, and some sites have more than one server, more than one router, more than one switch. So that would take entirely too long, right? Especially if you're doing something like an 8-hour shift, 40 hours a week, that's just a lot for one person, two people, or just the whole team, because you still have to turn tickets in your regular job and the regular day-to-day life. Like, it's a lot. So automation helps with operation cost, right? We're not working around the clock 24/7 to get this done. Automation is going to help us while we're still doing our day-to-day work, right? Automation also helps us so we can have our redundancy, our higher uptimes, right? So if anything goes down, we're alerted. If anything is coming into an error or has an error, we're alerted immediately, instead of when we are signed in or when we look at something or when a system logging message come in and we're like, oh, we're actually monitoring it. No, the automation side, that method, whatever the method may be, will say, oh, I see an error. Let me fix that. Therefore, it's not down to where I have to come in and fix it. The computer's going to fix it itself, right? And then with the computer fixing it itself, is going to have a low chance of errors when you are configuring, right? Let's put this down so you guys can know, because again, you should be taking notes. So why put automation in our networks, right? So we do reduced. Let me put that better. Reduced, I'm gonna just say cost, right? Reduce operational cost, right? We don't have to hire so many people, pay all this overtime for all these people, because automation is going to help us work within that 8 hours, within that 9 to 5, while we're still making sure that day to day is going fine. Because yes, you're over here configuring the 30 sites that we just did an acquisition with. However, some people can't make calls over here, that site's down, they need this, they need that, and then when you think about it, when you do a merger acquisition, maybe you feel the need to hire more people, right? That's more money dishing out. So automation helps us reduce our costs, right? Another thing it helps us do, it helps us have higher uptime, right? So of course, if there's an error coming in, instead of it alerting us, and then we have to go and log in and see what's happening on the automation method, whatever method we're using, that program or application, again, whatever we're using, is going to say, I see an error coming, or I see an error that happened, let me fix it immediately. I don't have to alert my human counterpart. I can just do it. I am a machine. I have I have the intelligence to go ahead and fix this error. Therefore, the site has a less chance of going down, or certain programs or certain things have a less time going down, at least devices, we're talking about networking, has a less time going down, because this automation method is going to ensure that it stays up to par. Okay. And with making sure it stays up to par, it's going to lower the errors. Right. So it's ensuring that it's online, it's doing what it needs to do. Any errors that come is going to fix it. And since it's programmed to do what we tell it to do, the errors, like, because we have human errors, right? When we do no shut, sometimes, well, at least on my end, I put no shit, like, whatever. That's not a big error, but it's still an error nonetheless. And our automation method is going to ensure that it's not going to give any errors, right? We're going to do it the right time, the first time, the right time, and that's it. It's over with. Okay. And just with reduced cost, you can definitely say effective staff, right? Effective staff, because instead of focusing on one task, I can focus on other tasks that makes the network improve better, right? So instead of we having this one person who's always SSHing or on the GUI, copy and pasting, making sure this and that and that, we can have them do something else that improves the business some type of way, right? Improves the network, right? Which ultimately improves the business. So our staff is more effective, right? They're able to do things that are actually effective than them doing the redundant task over and over again. And we're paying that person, $40, $50 an hour to basically just sit here and watch networking devices. We don't need that position anymore, because we have our automation method, right? Whether it's a Python script, SDN, Puppet, Ansible, whatever, to go ahead and monitor that for us, right? So in that turn, that person that was sitting there, just, ensuring that our devices are good, they're able to do something else that is actually productive. Okay. There are other things, but I feel like this is the best. These are some really good reasons why we want to use automation in our network. Right. It just makes it better. And that's why you need to really make sure that you understand everything that we're going to talk about from here on in this whole section, because this is why people are losing a lot of jobs, because automation is the big bang, right? We have machines that flip burgers. So who needs you to work at McDonald's now? We have self-checkout. Who needs cashiers now, right? We have the security robots at Walmart and Kroger and stuff. So who needs security to walk around and see if people stealing, right? We have these cameras, we have these things with technology, with intelligence, that we don't actually need a human body for. So with automation coming into networking, we don't need so many people in networking. All we need is the people who know how to set these things up. Because not everybody knows how to set up automation. Not everybody's on this new technology. This is very new, and it's very useful. So if you are the one that knows how to program the computer, then you have a job. All right. It's the ones that don't know how to program the computer. And this is why this section is the most important section. Whether you want to get the CCNA or not, it is important for you to know this information, because it's going to take you higher in your job. Whether you want to be in the tech field or not, you still need to know about how automation works, because if you're not in a skilled trade, electrician, plumbing, tech, something that is skillful, right, that not everybody can just go and do, then your job is at risk, because we can program a computer to do almost anything, right? We can program computers to build cars. So we don't need the warehouse, the assembly line. We don't need those General Motors people, right? We can have a program to do customer service. We don't need to hire you as a customer service rep, right? So this is very important that you guys take this section, if not the most serious of any other sections, because this is what's going to help you ensure that you always stay employed. Okay. All right. Moving on. So how does this automation work, right? Now, automation in our networks is enabled through a controller-based type of network, right? And that's what we call software-defined networking, right? Because we are networking, right? Computer networking, but in a software-defined way, right? We're doing it in a software. So SDN, again, software-defined networking, it is a controller, right? As you can see here, we have our controller. And what our controller do is it centralizes our task. It centralizes the network's configurations or patches or upgrades, whatever you may say. And it does so, and it's going to give out these controls via an API, right? API is application programming interfaces, right? Or interface, right? So this would be, these dots right here would be considered an API. An API is just a interface that allows one software to talk to another software. That's all an API is, okay? So when you see API, and you probably like brushed over it because we've all seen API, even in Facebook. If you use Facebook or Instagram, you may see API when you're trying to integrate certain apps or use it. Maybe you're using, I don't know, with so many different type of apps that work with Instagram, work with Facebook, that you can like repost stuff and just things in that nature. You'll see that it has API when you're downloading it. And a lot of times we don't care what API means, but in a sense, what it's talking about is it's saying that this software, it can talk to that software through a API. That is how softwares communicate with each other. Okay, so when you see API, just know that there's a specific software talking to another specific software. A great example I can give, because I actually use it in my business. So when I send you guys emails, right? I send a blast to everyone to say when's class or what's happening, and technically speaking, whatever the case may be. I do that from my website, but my website has an API to my email platform, right? Because my website's just my website, but I need a emailing platform, email marketing platform that allows me to blast out emails and send them out in these funky little ways and design them. So the only way that my emails can get to you guys, which are on my website, is through an API. I have to have this API to integrate these two apps so they can talk to each other and I can get that task done, which is email marketing, right? So just be mindful when you're doing things like downloading apps or, going to the app store or just maybe on a website, whatever. Pay attention to the acronym API, and then you can kind of get your wheels turned to say, oh, okay, so my bank app is going to talk to another app, like QuickBooks app or whatever, or whatever, I don't know, but just kind of pay attention to that. You'll be surprised how you see API a lot of places. So let's just take a look at this example. We have a traditional network. Okay, so our traditional network, we have our networking devices, and in this example, it says our switch, right? This is our switch. So in these network devices, we have a control plane and a data plane, right? Our data plane is what sends data. That's our IPv4 packets, our IPv6 packets. That's our data packets going back and forth. Hey, sending messages, right? And then we have our control plane. Our control plane manages our data plane, right? So yes, our data plane is sending messages, right? That's just our packets. Think of data plane as just packets being sent through the network. But the control plane is what controls our packets, right? So what controls our packets? Let's think about it. How can that be controlled? So we can think of, the switch is concerned, MAC address table, right? ARP table. If you're looking at a router, we got our routing table. We got these things. And how do they get there? They get there by these protocols. And what protocols are there? There are OSPF, right? RIP. Like we have these protocols that control our data. So our control plane, think of it as IP protocols, and our data plane, think of it as the packets actually going through, right? So that's in traditional network. That's in every device, all of our network devices, our switches, our routers, our servers. We have the control plane and the data plane. But when we come to our SDN, our software-defined network, we only use the data plane on our networking devices. Why? Because we have a centralized controller that's going to basically be our control plane. Okay, we're going to say, hey, I want you to do OSPF right here, right? I want you to do RIP right here. I want you to do EIGRP right here. Okay, I want you to add port security on these ports, put port security on that. You know, I want you to be the root switch, right? We have something centralized that's going to be some type of obviously software that we're going to. It's like a website, right? Because it's software that's going to automatically do these things for us. We don't necessarily have to go into the switch and say router OSPF network 162 dot, like we don't have to do all that. Our controller machine is going to do that for us. How? Through APIs. Our controller machine, right, is going to say, do this switch, and I'm talking to you through an API. That's how they all work together. Okay. So traditional networking, network engineer, network administrator has to go in and into all these devices, right? Device 1, device 2, device 3, and make these changes. And again, it can take forever, right? I know you guys are doing the labs, and how long does it take you to actually build the topology, put on the stuff, and then you can start pinging, right? And then if you can't ping, you got to go back and be like, okay, so what happened here? What happened there? Like, imagine being in an enterprise setting, having to do that. That's a lot of time. By the time you're finished doing all that, it's lunchtime, and now you haven't did anything that's pertaining to like tickets or helping the company out anymore. All you did was configure switches for the first half of your day, or configure routers or whatever. So it takes a long time to plan that and then implement that and then make sure that it's working. But when you have our software-defined network, right, our controller-based network, the engineers and the operators, the admins, they can implement these changes quickly because all they're doing is say, hey, controller machine, right, I want you to put the wireless implementation here for security, right? I want you to put OSPF here. And you're just telling them where you want it to go, right? And you're setting it up. You're giving them the blueprint. And then the controller machine is going to go ahead and do that quicker than what you can do that. Okay? Because it's software defined and it's doing it through what? APIs. Okay? Now let's actually go in and let's talk a little bit more about the planes, right? I think that's important to go a little deeper into the planes. So look up here, right? We have our data plane, control plane. We have one more plane, our management plane. Okay, we didn't talk about that. Now, starting from the bottom, well, let's just know that this right here, this box, is our networking device, whether that's a switch, whether that's a router, whether that's a server, whatever, right? This is your networking device. Your networking device have these three planes. Obviously, the data plane. What is it? Packets, right? It is our packet. That's all I can say. It's a data packet. It's the payload. It's the actual data that you're sending from one device to the next. Okay. Now we have our control plane, right? Our control plane is, they gave me an example, OSPF, right? I'm controlling my data. How do I control the way that my data operates? Well, or sends or routes or whatever forward to the network. Well, we have static routing, right? Manually doing something, or we have OSPF, we have dynamic routing, OSPF, and all these other protocols that controls how our data works, how our data is going to be sent out. Lastly, we have our management plane, right? Now, our management plane is basically our overhead work, right? When I say overhead, you can look at the examples right here. Telnet, which we don't want to use, right? Forget Telnet. SSH, SMP, SNMP, and system logging, right? So our management plane is what we will go in and manage our control plane, and our control plane is going to control our data. Okay, that is the planes that are in every single networking device. Okay, And this is how we're going to describe how automation and programmability actually is going to work. Because we have these 3 planes in each device, so why not have a controller, right? A centralized controller, or SDN, to say, you know what, in each networking device, go ahead and keep sending these packets through the data plane. But we're going to take out the control plane. You don't need all that, okay? And we're going to move the control plane up to our controller, and we are going to be the ones to manage it. Okay? We're going to tell the controller what to do for everybody, and the controller is going to go ahead and do it through APIs. Right? Very important that you understand APIs. Okay? So that's what it is in a nutshell. Okay? Now, some of this controller, I'm going to say most of the controller, right, is software. So what is software? Software, when you think of software, think of like something that you have to download. Microsoft PowerPoint, which we're using now, software, right? Still something I have to download, something I have to manage. I'm the one that have to go in through these things. I mean, there's so many different softwares out there. When you're downloading, let's say when you're trying to make an app, make an application, you may use My Android Studio, right? When we're thinking about software as a service, right? Think about Microsoft, I think it's Microsoft Azure. Think about things like that. That's software. We're going to log into it with our username and password, right? Email and password. We're going to go in and we're going to say, do this and do that. And then our controller is going to talk to our devices to tell them what to do. There's no more need for the device to to have all of this. There's no need for you to have a management plane, control plane, as well as the data plane. Keep the data plane. We need you as a network device to only do what you are supposed to do, which is move this data around, right? And what we're going to do is we're going to centralize our location. We're going to centralize the control location to make sure that, hey, I don't have to go in and control it individually. I'm going to use one controller to go in and manage it and control the data through, again, a centralized location. Right? Now, what I want you guys to ensure that you know is why we are using, what is automation and programmability? What is that? Why do we use it in networking? And how does that help us in networking? Okay, these are the questions that should be answered through this slide. Well, through these slides, through this whole lesson. Lastly, how does it work? How does automation actually work in a network? Right? These are the questions that you should be asking yourself, and you should should be actually answered through this lesson. Right? Now, we're not going to go on any further, because what I want you guys to do is I want you guys to actually go in, read chapter 16, right? It actually goes through 6.1 through 6.3. Now, you can read to 6.3 if you want, but the whole purpose is to read 6.1 and 6.2. It talks about what we just talked about, maybe a little more detail, and maybe more so you can write your flashcards out, but just pay attention to these 2 lessons. Okay, so I just wanted to show you guys the Trello desktop application. This is where all of our exam prep notes will be stored. So if you have access to the exam prep notes, or you're in the boot camp, this is our Trello workspace that we will come to and collaborate our knowledge and questions, comments, concerns. You will still use the Discord for your primary communication, but this is where all the material is housed. And I just want to give you just a quick little run through. Now, right now, we are doing the CCNA/Net Plus learning. So as I do the lives or I do recorded videos, I will post them here. And as you can see, we're going to start off in this board, which is called the CCNA/Net Plus. You'll start here for all notes. Now, you definitely can click on this, right? And it will give you some information like the Google Drive. That's where everything is housed in our drive if you can't find anything. This is also where I will possibly tag you to say, here, start on this board and work your way through. These right here are the exam topics. You can click on it and see it's an attachment as well as a link. All right, click out of it. You can click into this card, which is the Computer Networking 101 ebook. It's just the ebook with the computer networking all comprised in it. Not as deep as the CCNA, but it talks about it in general. So you can get a general aspect of how computer networking works. Basically, how computers talk to each other, right? You get this ebook for free. It is $25 on the website, but since you signed up for the boot camp or for the exam prep notes, you get this ebook for free here. We also have the CCNA Quizlet. So these are our flashcards or play little games with the terms. So it can help you retain this information as you go through these modules. Each module, right, as you can see, has its own list. So we have network fundamentals, network access, IP activity, moving on. Each exam topic is listed in its own video. As you can see, the lesson 1.2, lesson 1.3, 1.6 and 7, and they're all here laid out for you. And then at the end of the section, such as section 1, you will have an exam, a pop quiz, just a test exam, just to test your knowledge, see if you retain some information. If you haven't, it would be best for you to go back and review the things that confused you or you just wasn't able to retain, possibly even going back to the Quizlet. But if you are confused and the videos are not helping you, the resources are not helping you, please utilize Discord and we'll be glad to get you caught up to speed.